Hello and welcome. This is day 2 of exploring the new regex functions in Excel and just more generally exploring regex. Uh, I started off thinking I was going to make one quick video that would, run through the 3 new regex functions. And then as I started trying to, plan that video, I realized that that was too much to take on. And so I did, one yesterday or 2 days ago, I guess, that just sort of went through some of the basics of what regex patterns are. And then after that, I thought, I'd do another one that would just covered regex extract and regex replace. And then the same thing happened again as I started kind of planning that video. I realized that actually the rabbit hole keeps going deeper. So contrary to my original plan, I'm just going to talk about regex extract today. I think this is sort of the logical order to go in because there are additional nuances that come with replace, where you have to get into, is this a non-captured group or is it a look behind that's not part of? I'll talk about that when we get to regex replace, but there's a logical step up here as well. Two other things I want to talk about quickly before I dive into it. One is I've seen a number of other people's takes on the new regex functions since I put mine out. And one thing that struck me about maybe not exactly all of them, but certainly very close to all of them, is that there was this general tendency to treat the actual regex code like sort of magic or a black box. Almost all of them encouraged people, as I think the original Microsoft blog did, to ask ChatGPT to create a regex, or ask Bing Chat, or ask whatever to create a regex, which I'm not strictly opposed to, asking it for suggestions, especially for help with interpreting a complex regex that you see, like what is going on here. It's actually really good at that. But a word of warning, be very wary of using these things as a black box, because you don't know what you don't know. And at some point, like whether it's, the difference between matching letters versus matching non breaking characters, or exactly how word break works, or whatever it is, like if you're just loosely describing what you want to ChatGPT and then having it give you a pattern and then just assuming that works, it's going to cause you problems. So look, there are always situations where you just need something right now, but just as a life philosophy, at least if you are under the age of 40, which I just about still am, anytime you say to yourself, I just need to figure this out right now, if instead you say to yourself, I'm going to spend a little bit of extra time understanding it properly, the amount of time you are likely to save over the course of your career by doing that now is definitely worth the payoff. So if you think that regex will solve some immediate problem that you have now, there's a good chance you will encounter other problems like that. And if you spend an hour watching a couple of videos like my first one, or reading some tutorials or whatever to learn the basics of regex and like understand some of the nuances of, like, when would you use a backslash W versus when would you use a backslash uppercase S as a kind of general capture term, it's going to be worth it. The last small programming note before I dive on into this is I've been promising forever that I'm going to share my esports lambdas, and I really thought I was going to do it before the next battle, but now regex is shiny and exciting, and I'm easily distracted, so I'm making regex videos until I get done with that, which seems to be stretching out George R.R. Martin style into a saga. So I suspect I will not manage to share my esports lambdas before the next one, or at least I won't manage to share a walkthrough of them. I might share the file. Sorry about that if you were waiting for them. They are coming. It's still on my radar, but this is what's happening at the moment. All right, so let's dive on in. Some examples of regex extract. So again, if you haven't watched the first video where I kind of talk through all the atoms that these patterns are built from, I encourage you to either watch that or just go download the file. I'll link to it again in this video description, and see that. But so let's start with a simple example. This is an example. The data and the pattern both came from the blog announcing the new functions. So we've got a bunch of names and phone numbers, and we've got a pattern to describe the phone number. And regex extract, the syntax is just from this text, extract this pattern. There are options for return mode that we'll talk about later. Case sensitivity, we talked about that idea the first time around, that you can say you want the pattern to be case insensitive if you like. So what is this saying? These square brackets, remember, mean a group. The 0-9 means a range. So this is any digit from 0 to 9, or opening or closing parentheses. the group means just any one of those characters, any one of the characters within the group brackets, and then the plus means that at least one, but up to any number of times. So in other words, some blob of digits in parentheses, followed by a space, followed by some blob of digits and dashes. So, this pattern matches that. Lots of other patterns match that as well. So yeah, I'll talk more about the nuances of the pattern in a minute, but let's talk about multiple matches. So that first return option. So the default, if you leave it blank, is 0, which is return the first match. There's a second option, which is to return all matches. I'll talk about the capture groups later, which comes with option 2. But for now, let's just return all matches here. I've wrapped it in a 2-row just so it spills out along here rather than running into my other stuff. And so you can see, these are all just kind of jammed into one cell, but it's returning each individual match. So you can pull out every phone number from a blob of text, every email from a blob of text. You can wrap that in something like 2-row, but you can also wrap it with something like text join if you want to kind of list them out. And you can tell text join what to separate them with, like separate them by commas, separate them by line breaks or whatever. Let's just do it quickly. So you can say text join. What do you want to split it by? Let's char 10, if you want to put it in that way, is a line break. And then you can just wrap the text and it'll spill out that way. Or you can separate them with whatever, a semicolon or various other things. Or you can just go back to spelling them all out. So that's the return mode. But the bit that I'm more interested in kind of drilling in on is somewhat to the point I was saying earlier about the black box. Like if someone tells you, hey, use this pattern to extract phone numbers, let's talk a bit about what that's going to mean. So first of all, this pattern matches all of these. Here is a string of parentheses and numbers followed by a string of numbers and dashes. Okay, that's a phone number. Here's another string. Oh, you can see that I've left my formula for randomizing these in there, but never mind. So here's another string that matches that pattern. Here's another string and another string. And here's something that has no numbers in it at all, but matches this pattern to be a telephone number. Okay, probably not ideal. It also does not match these. So here we have, and we're still using kind of 10-digit US phone numbers, so that there's still a regularity here that you won't get if you're dealing with, international phone numbers. But we've still got, 3 digits, and 4 digits, but now instead of this being in parentheses, it's not, and it's separated by dashes. Here you don't have, the lack of a space is the problem. Here it's just not split up at all, but you do have 10 digits. So it says, I've said it doesn't match these. That may or may not be a good thing. So, would you want a phone number match to match this? Probably. Would you want it to match an unpunctuated blob of 10 digits? Maybe not. Maybe not. May or may not be a good thing. So let's talk a little bit. What might a more careful phone matching pattern look like? So the big thing is it depends a lot on the data you're expecting. So again, this is where it's important to know what you know and know what you need to know if you want to ask ChatGPT or something like that. So, if you want a pattern that will match phone numbers, the big thing to think about is, are they all from the same country? Because phone numbers within one country typically follow a fairly restricted pattern. They're usually of the same length. There's usually an area code, which, well, actually even the area code, like in the US, they're all the same length, but in Ireland, where I grew up, they're not all the same length. Dublin is 01. Waterford, where I grew up, is 051. I think there are even some that get to 4 digits, but anyway, point is, they can look very different. It can get very complicated. That is definitely true. So here's a slightly different one for a US number. So main thing we're leaning on is, rather than just the plus here that means some number of digits, we're kind of restricting the number of digits. So here we're saying, there has to be a block of 3 digits, there has to be a block of 3 digits, and there has to be a block of 4 digits, but we're offering a little more flexibility about what comes in between. So here we're saying the backslash parentheses just is escaping, so it's not treated as a special character. The question mark makes it optional. So these 3 characters together mean there might be an opening parenthesis before the number. These 3 characters together mean there might be a closing parenthesis after the number. If you wanted to be a little more strict, I'm sure there's some way that you could make a regex pattern say It's only valid if there is either both or neither, but not valid if there's one or the other, but not both. Although I don't yet know how to do that. Then this is saying there might be either a space or a dash, and you could get rid of the question mark there to say there has to be either a space or a dash. But so that'll, like here, for example, it matches this number because you're not requiring a space or a dash. If you were more strict and you said, well, I don't mind if it's a space or a dash, but there's got to be something to split up the groups of numbers, then this is no longer a match. And maybe that's a good thing, maybe it's a bad thing. It depends on what you want. So here we can see it's pulling this out fine, it's pulling this out fine. It's sort of correctly saying this is not a US number in a format that we accept. This one, depending on how you write it, it might accept it or it might not. There are trade-offs to that. But it's getting complex compared to the relatively simple thing up here. It's already you've got a lot of escape characters and question marks and things that make it less easy for a human to read, and it's still far from perfect. So here, for example, if I add a +1 to the start of this guy's number, it matches the first 10 digits. So it's going to match this rather than matching this, which is actually the phone number. And again, there are ways that you could write a pattern for that. Here's a person with a credit card number, and it just assumes that the first 10 digits of that are a phone number. The thing, well, okay, so here's an example that I got from regex.com, which is considerably more high-powered, but obviously trade-off. Do you understand it? I could probably sit down for a while and parse through what is going on here. I'm not 100% sure I could, honestly, but so here's what it's doing. It is picking up that number. It's thinking of this as two numbers when I would say there is no valid number there. It's picking up the +1 here. You might or might not want it to do. It's matching this. It's matching this. The thing that I want to talk about is this, the trade-off between flexibility and validation. So the more flexible you want to be about, is there some possible way to interpret this as a phone number? Maybe if it's something, maybe this is some weird extended area code, and maybe this is something, maybe there is some part of the world where these 16 digits could be a phone number. Not sure. But there is a balance to strike. If you're primarily using this to try to validate, has somebody entered a valid US number, then you want to be quite strict, among other things, about are there exactly 10 digits or maybe a +1 in 10 digits. But you certainly would not want to accept anything with 16 digits, and you wouldn't want to extract a subset of that. Again, this is the kind of thing, if you just say to ChatGPT, hey, give me something that matches phone numbers or extracts phone numbers, you're going to miss a lot of nuance. So anyway, that's all kind of about phone numbers. Let's talk about extracting email addresses. Again, this is one of the most simple patterns that you could use. So this is just any \S is like any non-space character. So that some number of times, so this just means that if your email appears in text, that the space right before the email starts is going to be a sort of section break. So that's some number of times, followed by @ followed by some other number of characters. We escape the period/full stop to make it a literal, and then this some number of times. And again, there are subtleties here, like there is a .co.uk domain, which oh, interesting. Yeah, sorry. So I was thinking it would fail to match that, but of course, because I'm using a very broad group here, which is anything other than a space, it's actually happy to match much longer and weird looking patterns. So again, trade-off between flexibility and validation. But if you used something more tightly defined here that was, for example, maybe it was a /w to pick up letters and numbers, and maybe you also add, I don't know, plus, dash, period, whatever else you add, then you would need to, well, you probably shouldn't include a period in the domain name. Then you'd need to add the possibility that there could be more, more dot somethings at the end. And maybe you want to control how many there can be. I don't know. Again, there's a big difference between just grab anything that looks like this. That's my list of like potential emails, and then maybe I'm just going to human filter that, or maybe I'm just going to drop them all into a 2 field in Gmail, knowing that it just won't send anything to something that's not a valid email. versus if your aim is validation, and that's validation is quite a bit more complicated. So there is a standard called RFC 5322 that defines what is a valid email. This has, I think, actually since been replaced by a more complex one, but I just found a regex that validates emails according to that standard, and this is what it looks like. And it is a lot. And if you look at the Wikipedia article on email addresses, like there are, it's very easy to think about, what do email addresses that you typically see look like? But if you actually push the extremes of what is an email permitted to be, there is some really weird stuff. So, like for example, an email can't start with a period, but it can start with a quotation mark and then a period because the quotation mark is considered to escape the period. There's all kinds of like things that would not pass the human sniff test of is this a valid email can in fact be valid emails. And again, you got to think about what are you trying to do here. If you just have like blobs of text and you want to take out things that look like email addresses, then a really simple pattern like this is probably a good way to go. If you want to validate, have people entered correctly, or maybe it's at like a work thing and you want to make sure that everybody has actually entered their work email address and not their personal Gmail so that you're not sending things outside the company or something like that, then you want to have a more restrictive pattern. And again, once you understand these nuances, you can certainly go to ChatGPT or whatever and say, hey, I want this. I'm very focused on validation. It has to be at this domain, but let's be very flexible about whatever piece, or it's smart, but if you don't know to add these qualifications, it's not going to prompt you. It's very good at just saying, here's the answer. So let's talk a little bit about more complex extraction and capture groups, because capture groups are one of the big kind of differences. We talked a little bit about some weird cases yesterday, or the day before yesterday, where you might need to capture something in the context of just matching a pattern to be able to say, does this happen again? But when you get to extracting, capture groups really become much more relevant. So the data that we're looking at here is a Senate vote session. So on Senate.gov, there's records of every vote cast by the U.S. Senate since 1990, I think. I've played around with this data in various forms before, but it's very unhelpfully presented. Like it's very human readable, but very not machine readable. So like if you go to access this page with Power Query, there is no macro structure that will help you to identify this is a table which contains 100 senators. This is another table that contains, I mean, this one is especially bad because it's, the vote is not even a column in the table. But like this one is in a reasonably useful format, aside from the fact that it's in 3 columns, whatever. But there's no kind of table tagging or anything. It's extremely hard to extract this with Power Query. But if you press Control U on Chrome or on Edge I'm on, but on whatever thing you're on, then you can get the source code from this, the HTML, and so that there's no good sort of macro structure, but there is a very clear microstructure of what these things look like. So I have taken the HTML from here, and this is enormous, tens of thousands of characters, whatever, but that's fine. I think more than it will even show in the cell. But and then I've written a pattern to try to find, basically what does this blob that is a particular senator, their party, their state, and their vote look like. And if I just kind of copy this out as far as there, let's say, and put it next to this, it's sort of fairly easy to see the parallels between them. So, we want something that starts with this closing HTML bracket, greater than sign, whatever, then is some string of letters, followed by a space, followed by this, again, this escape just means a literal opening bracket because then the party and state is in parentheses. Then we have a group here, which is any one of, this pipe character means or, so it's either R for Republican or D for Democrat, or weirdly they have independence coded as both I and ID. Don't know why. Then a dash, then 2 uppercase letters, which is the state code, then a closing bracket, comma, space, then bold, then some number of letters and spaces to represent the vote, and then the end of bold. So you can do that, and it can extract all of the different votes. And I've wrapped it in unique just because there are some, I think there are two different tables that match this format pattern. So you get, you can see I've got a count of 100. There are 100 senators in the U.S. Senate. So you can pull that out. But the interesting thing about this pattern is, aside from the escaped brackets, you'll see that I've got these sort of group brackets. So like here, I just need it because to have this or that, where some of them have multiple letters, you can't just do it in a group. So if it was just R or D or I, you could say RDI in square brackets, and it would say any one of those characters. But if I need some of them to be, so if I added ID for the other way of saying independent, then this would just be saying, it would still just be matching a single character that's R or D or I or D. Whereas if I wrap the whole thing, yeah, in parentheses and put the pipe character between them, then it's saying one of these. So it can be ID, but only if it's exactly that, or it can be one of these three letters by themselves. But I can also basically wrap any other piece of this in parentheses to say I am interested in capturing this. So, this is the overall matching pattern, but I'm interested in this subset, which is the person's name. And sorry, actually, I need to include the plus there. So this, when I match some number of letters in between this greater than sign and before a space and before all the rest of this pattern, I'm interested in that piece. That's the senator's name. This piece is their party. I'm interested in that. This piece is the state. I'm interested in that. So I can wrap that. And then this piece is how they voted, and I'm interested in that as well. So I wrap all of those in parentheses, which are called capture groups. And then you can see, I'll show you exactly how in a second, but you can see that allows me to split out. So I don't just capture, here's all the blobs that match in general, but I capture here are the specific details. So I get from this sort of very messy format, which is, punctuated in a variety of different ways, into a sort of neat data table that I can then work with. And so the way this works is, remember I mentioned earlier that there are three different capture modes. So you can have the first match, you can have all matches, or you can have capture groups of the first match. So actually, it's probably easier to see this if I go over to regex101.com. So here I've put in my pattern, and I've just pasted in all the HTML code, and you can see what it looks like here. So each of these light blue sections is a match, but then within that there are 4 different groups. So there's a group for the name, there's a group for the party, there's a group for the state, and a group for the vote. And you can see in this one, I had actually only allowed for letters in the vote, and that was actually, again, this is the nice thing about Regex 101, is it lets you kind of visually scan the data. That was not picking up not voting, because you also need to allow for the possibility of a space to pick that up. Yeah, so the idea is that just lets you see, okay, so in this big blob, a match is each of these blue bits, and then the first capture group within each of those is green, the second capture group within each of those is orange, and so on. Now, I would love if there was a way to say, much like you can kind of text split a blob with, one delimiter letting you say when there's a new row and another delimiter letting you say when there's a new column. I would love if there was a way to get directly from this data straight to this table. At the moment, there's not. Still beta, maybe there will be later, but what you can do instead is first you can extract all the matches using this pattern, and then using the same pattern again, you can point it to each one of those and say, give me all the capture groups within that match. So I've hidden most of the rows just to kind of spare you, but you can see that gives you all 100 votes. All right, video is getting a little bit long now, so I'm going to park it at that for regex extract. And the other thing I want to talk about briefly today is using regex functions with dynamic arrays, because you can and you should. So a few things. There are some pluses and some caveats. The first thing is the new functions are, broadly speaking, dynamic array friendly. So, here is the regex pattern we used before. If we want to test this whole range, we can say test it based on this. If we want to extract from that whole range, we can do that, no problem. But I added to a point. So there are, Excel is struggling, for want of a better word, with the concept of arrays and how to best manage that. So like text split being a good example. If I say, oops, if I say text split of this by space, let's say ignore empty, then I get each of those pieces. But if I then apply that to the whole range, I only get the first piece from each one. And basically these functions work very much the same as that. So here, if I say I'm regex extracting based on option 2, which should be giving me all capture groups. So let's just show you what it looks like if I apply it just to one cell. This is capturing the name and the phone number. But if I apply it to the whole range, it's only giving me back the first match. So exactly the same as the behavior you have with text split. And likewise, if you have one blob that contains multiple matches like that HTML code, or like here with a bunch of names and a bunch of phone numbers associated, you can extract all matches from the first capture group. So in other words, I can extract all the details about Sonia Reese, or I can extract all the matches, which would just kind of basically give me each of these rows in its own separate cell. What I would love to be able to do is to make a sort of 2D split on this to say, each group, which way around? Sorry, each match would be a row and each column would be a group. Right now, not possible. But if you find yourself needing to do something like that, here are a couple of workarounds with Reduce. It's a pretty well-known pattern if you work with lambdas and arrays. The idea is you start from anything, which we're going to drop at the end, just because you can't start from blank, and iterate through. So this is the multi-cell version. Iterate through each cell, and at each step, you take what you've got so far and your new cell, and you VStack what you've got so far above whatever you need to do with this one, which in this case is extract all match groups, so option 2, and then flatten that out into one row. So then you stack them up, and then you end up with 0 and then all your different matches, and then this says drop the first row of that, which gets rid of the 0. And pretty similar idea here if you're working with data where it's all in one cell to start with, except that then the array that you're going to iterate over is a regex extract where you extract all the matches. Sorry, I keep mixing up matches and groups. Yes, all the matches, and then for each one of those, you would extract each capture group from that. All right, quickly, filtering to matches and non-matches. So here are some names and some emails, some of which are bad. So here there's no dot anything, here there's no at, etc. Here is, again, a very simplistic email matching pattern. So here I can say filter to valid emails. So I just use regex test to return an array of trues or falses, which is exactly what filter takes. So I can say, okay, these are the names that have valid email addresses, or here are the ones that have invalid email addresses. You just wrap it in not. So regex test says, the first row is false. In other words, that's bad. The second row is true, and so on down. You just wrap that in a not, and that inverts them all, so you get true, false, false, and then you can filter based on that. Likewise, you can filter with extraction. So here's something that mixes, the name and the email address, and I'm interested in filtering out valid emails. And you can see here, because the email is in parentheses, I've had to use a slightly more carefully or slightly differently written regex, because if I used the /s that I had before, it would pick up the parentheses, and if I use the /s at this end, like I did before, it would pick up the closing parentheses. So again, just depending on context, different things to do. But what we're interested in is I want to so first extract the emails and then just filter out only to the ones that are valid. And the way you can do that is first regex extract, which will give you NAs where there's no match and the extracted piece where there is a match, and then you wrap that in 2col, which will drop. If you use the argument 3 or 2, those will both ignore errors. And so it effectively acts as both a filter and an extract at the same time. And then last thing, XLOOKUP and XMatch, they've let us know that there will be a regex matching option coming to both of these at some point soon, but you also don't have to wait for it, because regex test and XLOOKUP and XMatch are both array friendly, and it's easy to combine them. So here we have, again, an email matching pattern. So if I want to say match the first row where there is a valid email, then I just, instead of matching this pattern, I just match true against what I get when I apply this pattern. Simple. And likewise, XLOOKUP, I can look up true in regex test here. In this case, I only have one column, so I'm just returning that column, but you could also return from a different column. So lots of fun stuff that you can do with dynamic arrays. That's all I've got for today. I will be back early next week with more fun around regex replace, which is probably the most complex of the three, in that that's where you have to get into not just capture groups, but also look aheads and look behinds to be able to do some of the same things, or some of the sort of equivalent things. But you can also do some really cool things with, like, a regex replace to rearrange, a name from last first to first last is really simple to write. Things like that, where you can kind of replace to shift the pieces around in a way that's quite cool. But anyway, that's it for today. Thanks for watching. See you next time.